Okay, so welcome back. In part two, we'll address, is it just repeating or reasoning, hallucinations, biases, and prompting techniques. The reason why this is titled Prompting for LLMs is because whether you're using GPT, Sonnet, Llama, or whatever you might choose, as long as it's an LLM, all these things will be apparent, and the prompting techniques should transfer to just about everything. So, getting started. If you've heard the phrase stochastic parrot, what that refers to is a paper that was written in 2021 on the dangers of stochastic parrots. Can language models be too big? And some of these claims are there's possible biases, the models consume significant energy, they might negatively impact certain groups due to the biases, and the key focus was around whether the models truly understood language or merely just mimic it. And what this term really means is stochastic, like it's very random from the mathematical sense. And what does a parrot do? It repeats things without really knowing what it's saying, except for maybe African grace. But anyways, this image was created using this. As you could see, if you see something that says prompt, it likely connects back to the image on the slide. And yep, that's what is meant by stochastic parrot. Now, moving along in 2024, there was a paper released by MIT, Abstract Reasoning, and it delved into putting GPT in different tasks. And these different tasks range for multiple things. Arithmetic, code generation, and multiple different things that you would mostly, I guess, relate to math, which is usually more difficult for GPT models to come to conclusions. However, as we can see, it's not completely random because there's a random line where although the performance drops off from the blue, which is the starting state, to random state starting. I guess I should have covered this. Default is the, say, starting from a normal standpoint. Like, have you ever set a game of chess? You always start in the same point, and then you move along to some progression, which you don't know what it might be, but you always have a starting state. However, what this paper discussed was going to the counterfactual. So random state, throwing a GPT into a situation so we could measure how much it could reason or how well it could reason. There's a line just for about everything on randomness. And although we see performance drop off every time, I think most humans would also drop off if you're not at the starting state, right? We could see this specifically in chess, since it is a very complicated game. However, when it comes to code generation, we see about a 50% drop off, but it's not significant in something like chord fingering or chess, like I said. Some of the key findings here say that for these tax examples, we just need to maybe do future research or enhance how robust a model is and perhaps making it more general, if that's even possible. So moving along to what is model temperature? Model temperature refers to how random a model is by default. ChatGPT has a temperature of 1, the lowest being 0, and high temperature up to 2. So why is this built into models? Well, there's plenty of arguments that discuss temperature and how it's used or why it's used. The main point being that the lower the temperature, the more factual a model is. The higher the temperature, the more creative it is. But it's also more random, right? So you can end up with some really strange responses or close to hallucinations at some point. You could also go extremely factual and just get very cookie cutter information, something you could have just copied and pasted out of a book. So that's the reason for temperature being built in. As I said before, GPT by default has a temperature of 1, but this is very concerning for different fields of AI, right? Say if you're in healthcare, you want this to be as factual as possible. If you are, say, an artist, you might want this to be like a 1.5 to be as out of the box as possible. So it really depends. I've linked GPT Playground. So if you have a paid account, you could actually go to Playground. And here, I won't go over the platform since this is strictly only paid. But for those who are paid or have this account already, you could create a system, enter whatever, and you could tune your model, play with it. So say you want to integrate this to some service or application, you could go here to temperature, notch it down, maximum number of tokens. You could use it to stop or segment sentences, and you could do a bunch of other things. That is, I guess if there was a part two to this workshop, we would create our own GPTs using this API. No. But was that a question? No? Okay. Like I said, if there was a part two of this workshop, this is something we will look into in creating our own GPTs or agents for services. But for now, we'll go ahead and exit this. Now, an introduction to hallucinations. So what exactly is a hallucination? Well, this refers to something that a model does and it's not expected to do. Some people prefer the term. Okay. Okay, if it is a question, let me know. So some people would prefer the term confabulation. However, hallucination is widely accepted, and that's why we repeat to use it. Now, the debate goes into creativity versus reliability, practical impacts, and the future outlook. OpenAI has done a pretty good job so far of mitigating all these hallucinations and instead leaning more towards I would say, even though factual, but more creative aspect. So the image of this robot was just a prompt of a robot hallucinating, and I turned up the temperature all the way up to 2, and that's what I did. So it's not too crazy, but it is pretty creative because as you saw from the images before, we saw a lot of almost realistic art. Now this goes into more of a cartoon or a comic book type of creation instead. Next slide is, why exactly do models hallucinate, other than the argument between creativity and how factual something might be? So models hallucinate for a couple things. They don't have a built-in lack of I don't know factor. They'll always try to give you an answer, especially if you have it connected to the internet. They'll search for that specific thing. The way you can overcome this is by telling the model, hey, it's okay to not know, just tell me instead, or provide suggestions if you don't know. There's also the, I guess, internalizing of false information. Like I said before, we don't know exactly what data set this was trained on. So it's likely that some false information can be sprinkled in and perhaps move the model to a specific political group. Now, OpenAI has done, I would say, a lot of work to remove all these biases by doing some tuning, but we still have other things like the inability to trace back. So if you have a long conversation with a model, sometimes the beginning things, it won't exactly remember it. For example, regenerating an image, it can't exactly go back to that because it just pushed it out and didn't internalize it. In the real world sense, we could see that even though we could improve things ourselves, we just need to wait until the corporations do it themselves because it takes a lot of time. And these are just things that I kind of went over already. So examples of practical methods to reduce hallucinations. Some of these things, yep.
Have a sense on like how much of my conversation is kept track of? Like, should I think about a certain amount of characters, a certain amount of prompts? Like, yeah, like when after 10, yeah, basically that.
So how much information is retained is honestly dependent and on the conversation. Personally, I've gone back to chats that have been, say, 2 months old, and it can still respond. However, there's been times where I worked on a data set last week, say a mock data set that I was training on. It will no longer remember the process. So it'll completely go back to the beginning and say, hey, let's reload your data set so we can do the process again. And I think that's likely due to how much information is being held within each chat. Something like text might not be, I would say, might not take as much space as something like data analysis. And these are practical methods to reduce hallucinations. So telling it it's okay to say, I don't know, that's number one. Be very cautious with long context. So what happens is that if you provide an extremely large prompt, it'll do a really good job of understanding the beginning and the end, but not the middle. I'm not sure if I learned that behavior from us, but it seems like it's that way, right? Now, using formal language, as I mentioned before, you could say, hey, talk to me as a professor, as a researcher, as a colleague, and so on. And it'll be able to pick up on those nuances, vocabulary. And ongoing evaluation. I know I said this a bunch of times now, but never use it to completely replace your work, only enhance your productivity. And these 4 things, you can build them into Customize My GPT directly, and it'll actually do a better job at reducing the hallucinations that it causes on any given case. Now, there's challenges beyond the hallucinations. They're, like I said, biases. Some of these to be aware of are gender, cognitive, geographic, and language biases. We've used reinforcement learning to try to mitigate these, and it does usually a very good job at being neutral on most controversial topics now. It was not like this a couple months ago. And although this is good in theory, we always have the almost, I would say, drop off that if these reinforcement learning people have some type of biases themselves, they'll actually build it into the model. So that's something to be very aware of. The future directions of ChatGPT and in general LLMs is to be as unbiased as possible. And that will only happen with time, more data, and more reviewing of outputs. Now, on to the technical aspect, where we interact with GPT again. So prompt techniques. The first one is active prompts. So what is an active prompt? So this just means going back and forth with a conversation with GPT. It's able to adapt to new information, new requests, and so on. So let's go ahead and open GPT itself. So our first prompt will be to explain linear regression at a fundamental level. And as we've seen before, it's able to generate the text pretty quickly. And it'll go over some math concepts. And it doesn't always do this, but it's actually giving me an example this time. And some assumptions. So one of my favorite follow-ups is explain it like I am 5. So what this does is it shifts the output from being pretty textbook to very simple. And I often do this whenever I'm trying to understand a new topic. I'll go, explain to me like I'm 5, like I'm 10, 15, so on, until I get to graduate level. So this is a really good way of showing how prompts can adapt to you, how you can maybe look for more information, or you could even provide it with new things. So the next thing we'll do is we'll say, write a Python function for linear regression. And that looks just about right. And as you can see, it writes the Python function for me using NumPy, which is probably the most useful library in Python. And it also tells me how it works. Because I went from that step of explaining it to me, it knows that it doesn't just need to spit out code. It also knows to provide me with some context for the code. Like I said before, this is probably the best learning tool you have. And now, an example output. So based on the array that it provided, it'll provide you even the expected output, the slope, and so on. Now say that we're not happy with this. So we'll write something like implement this in a multiprocessing level. And it'll actually go back and write this in a multiprocessing manner. It does a really good job. If we had a little bit more time, I would copy paste the code, make sure it runs, set up the environment, and so on. But I trust this pretty much to at least write the skeleton code whenever I'm working on a project and just get started. And that's how reliable it is, going from CS and learning everything and then realizing, hey, this could do it a lot better than me, a lot faster. And you could also shift, like I said. And as you can see, I said, write this in R. I didn't provide the context of this is a programming language. But it is able to pick up on it pretty quickly. And it'll apply it again. So this is a very good example of an active prompt. Again, it's giving you how it works, just a different interpretation in a different language. Now, the next technique we have is prompt chaining. So if you already have a process like the one we went over right now, you can just break it down in these steps and provide to the ChatGPT model. So it opened over here. Let me drag it. Okay. So let's go ahead and write a prompt for this. We'll say, do the following steps. So now, instead of being a reactive prompt, we can kind of make this a little bit more autonomous by copying and pasting the steps. And I'll list them out. This time we left out the part of explain to me like I'm 5. I no longer need it because we understand it. Where this comes in handy is if you have access to the API, or you want to automate specific processes, or you're creating your own GPT, you can start to have a bullet point list, and it makes it very reproducible every time, since it's going step by step instead of waiting for a reaction for a prompt. Do we have a question on chat?
Person said that they hit the plan limit, so it won't give them any more code.
Okay. If that happens.
Like, what's the, if you give us an idea, like, will they be able to start a new conversation and get around that limit, or like?
Yeah, so I think the limit is reset just about every 2 or 3 hours.
Okay.
And I think it depends on tokens. So how much text are you really generating? It doesn't make a difference whether you're generating code or generating text itself. What it really matters is how many characters is it producing. So that's pretty cool, but the next technique that we have is few shot. So what is few shot? what if we don't necessarily know the process, or we want the model to be able to, almost like machine learning, learn from data being fed in and learn a pattern? So how do we do this? We do this by providing usually anywhere from 2 to 5 examples. And we'll go ahead and do that right now. Where's my cursor? There it is. Okay, and we are going to give it a summing problem. And I believe this example actually comes from the Few Shot publication that came out in 2012. Go ahead and format this. And before, what GPT would do was that the model itself would get very confused between numbers and text within the same prompt. So it was really bad at, almost like kids, problem solving when it came to math problems. So now, if we provide this to it, we'll skip a line. We'll be able to catch the context. The answer is false, and it'll tell you why. This is a very simple example, but you can scale this up to pretty much anything. So say you're a creative writer, and you want to make a new script. You have 20 example scripts. Drop them in. It's able to pick up on your patterns, terminology, style of writing, and it'll produce a new piece out for you in your own given style. You can almost think about it as Markov chains, right? It's recognizing these hidden patterns and being able to contextualize them. Now, possibly the best prompting technique that you have is chain of thought. And chain of thought works in a couple ways. When you really think about it is, say you're trying to problem solve, and the final answer is either extremely dependent on previous information or things that you need to solve, like, say, a multi-process mathematical problem or logic problem in this case. So what we'll do is we will tell it very specifically, do this step by step, or do this and explain your process along the steps. This allows you to do 2 things. It's breaking up the prompts, so it's checking its logic every time. And number 2, it's also a lot easier to debug and see where any of these defects happen. So we're going to give it a logic puzzle. And our prompt says, Michael is a 34-year-old from America. He is at that really famous museum in France looking at a famous painting. I'm pretty sure a lot of you know what museum, what painting. Now, however, the artist who made this painting just makes Michael think of his favorite cartoon character from his childhood. Now it starts to get a little bit more ambiguous, so you definitely need the information in the previous sentences. Let's go even a little bit more ambiguous, which is, what country of origin is the thing of the cartoon character usually holds in his hand? So now it's like, okay, I would need to break out my old logic book and write this out in statements and so on. Does anyone want to take a guess on the correct answer? What did you say, Paul? America? Okay. So
Japan?
we are actually going to see what, was that an answer over there? Nope. Okay. So we are going to say what GPT says. And it says, based on your description, it seems like Michael is at the Louvre Museum. Okay, that's correct. That was pretty obvious. And then he's looking at the Mona Lisa. Okay, cool. Then it's looking at possibly Leonardo from the Ninja Turtles. And that turtle quotes katanas, which are swords from Japan. So it did it right this time, but it doesn't always do this. And that's what I meant by some of these prompting techniques are becoming almost obsolete in GPT. But if you go to something like Sonnet or Llama and other models, you'll grab these techniques and put them in place so it can benefit from them. If we go over to our next slide, will be self-consistency. So what does this mean? This means that we open up multiple chats for things that are a little bit ambiguous. Like it could have been a couple of things when you really think about it. So what it relies on is context. And what type of context? Cultural context. We know that the Ninja Turtles are a cartoon that aired maybe about 34 years ago, right? And he's a fan. Why? Of what turtle? Michelangelo. It makes these connections. But it's not always able to do this. And especially when these LLMs are trained or say trained on such a large corpus, it can make the wrong connections. Now, so what we do in this case is self-consistency. We open up multiple chats, and we are also going to add the step-by-step portion. So I was playing around with this logic puzzle, and if you actually change the age, it'll give you a different answer. And that's because it's based on context. If it goes to about 28 years old, it'll actually say the country of origin is Italian because Mario came out at around that time, and it relates it to video games instead of the Ninja Turtles. So we'll go ahead and open this. And by listing step by step, so this is now a combination of chain of thought. We said, hey, do this step by step, and we'll open another chat to check the different answers. And as you can see, now it only walks you through your logic up there, then it summarizes every step. You could do this with math problems, logic problems, whatever you might need to. Now, if we open another chat, actually, I wonder if I go to the legacy mode, but do this well of a job. Okay, and this time it's giving us that it's extremely ambiguous and it doesn't really know. So let's say once the cartoon character is identified, the next step would be, so now it doesn't want to tell us. That's interesting. So we can say take a guess. Okay, so now it got it right again. Strange. Usually it takes it fails like every other time. Let's see if we hit one. Okay, and see, now it fails. So now that we've got a failure, if we really wanted to, we could keep on testing, and it would almost be like sampling, right? Or we would just take the majority if it's extremely ambiguous, and then we would go along with that. Now, this takes a very long time doing it by hand, but if you have an API and you're trying to go through these processes, you can automate this You could also streamline it. You could do multi-processes. I've done 1,000 at once. So it could really scale up. And that's the whole point of this workshop, is to just provide you with the tools and background knowledge so you could then apply to whatever you need. So the next slide is generated knowledge prompting. So what exactly does that mean? Well, as we remember, ChatGPT is trained on a specific data set, and there's a cutoff date for this knowledge. If something new has came out, we could ask it to search the web. However, it doesn't always work that way. Maybe it's not able to find the correct documentation, or perhaps we want it to use our own knowledge, something that's not available online. So in that case, we are going to update it. So our first prompt is going to be, tell me about open source in, quote source twice, thought so. And it goes ahead and starts giving me a bunch of information about open source within AI, as we've seen before. And we can expect it to finish in time. We'll go ahead and actually open a Google Doc of mine, which is a different interpretation on the current state. And yep, this is kind of like an outline that I used for. So using this new information, redo your article. And I'll go ahead and read it, summarize it, and embed it with my own information. So this doesn't just take my own information, it uses previous knowledge. And whatever clashes with that previous knowledge, it actually takes it out. But whatever is left ambiguous, or whatever is not specifically specified, it will combine it with my own knowledge, creating a new instance. So this is how you could supplement your writing, right? This is how you could supplement your programming. Things often change. So if you're asking ChatGPT, hey, provide me with code to, oh, that's long. Provide me with code to generate something or to process something. And you go grab your code, you paste it, and it gives you an error. Why? Because it's out of date. Then you go to the actual documentation, copy and paste either the link or the documentation itself, and you say, using this new piece of knowledge, give me the source code that will work. And then you're able to overcome those past issues. So that was generated knowledge prompting. Yep.
Yeah, like for example, take trade laws and ask them, ChatGPT, could you find trade laws that?
Oh, like trading laws, like arbitrage and all those things?
No, like international trade laws, for example.
Yeah, yeah. Yeah, so yeah, that's a really good implication, actually, because you need to be as factual as possible. Right, so first I would say, hey, you're a lawyer. I would say, you're an expert on this. Then I would say, using these updated rules on trade laws, generate and then give it the prompt. But you need to kind of set up the stage before you get to it. I know there was a case recently where a lawyer is going to jail, right, because he wasn't up to date. He was using ChatGPT to generate the laws, but they've changed. His interpretation is he didn't understand how it worked. He thought it was a search engine. However, when you're doing something, that is within the law, you should update the model, because as we've seen, generated knowledge prompting allows you to update it, versus before it's up to date maybe like last year around October. Some people August apparently. So that's a way to overcome that issue. And it'll be very similar when it comes to Sonnet or Llama and other things.
Right? We have to provide it every time we start a new chat, or we
Yep.
should assume it.
Yeah, so
learned?
every time you start a new chat, you'll need to provide it. And this is where, remember those custom GPTs come in handy? So you could then make a custom GPT, use some of the prompting techniques that are relevant to your problem, and create that custom GPT to then handle whatever task you might need. Question, Paul? Yep. In a way, feeding it information is the best way we have as of now of tuning the model, right? Or updating in some way. Now we go into React prompting. So React prompting is very similar. So it's just a technique to the previous one. And the definition says it combines reasoning and acting within the same framework, enables models to handle complex tasks by integrating logical reasoning with actionable steps for allowing both to go through and execute. So what does that mean? It means that you take all of our old prompting techniques and write them together, perhaps paste them into a custom GPT, or have a document already if you can't create custom GPTs. Just copy and paste it, drop it in, then it sets the stage. And you can go through more complex things like solving math problems, programming, writing technical papers. That's what React prompting is. Now, there's also directional stimulus prompting, which is the last basic technique that we'll go over today. And this technique says, hey, there's inherent biases or possible inherent biases within our model. We want them to be biased, but like the other way. So we're going to go ahead and do that. So just to check the bias on this model, we can give it a simple prompt like, should education be free? And we'll see what the model says. So it gives us the politically correct jargon of whether it should be free or not is philosophical and depends on other systems, right? Now, say that I want education to be free, and I wanted to write something that says education should be free. I could say, I think education should be free of cost. Write a small argument using your information. So I'm just going to follow up with a prompt, write in bullet point format with headings. So that way we have an outline of why education should be free. However, what's very useful when it comes to debates or writing, we could say steelman the opposing side. And for those that aren't familiar, steelmanning means provide the opposing side's best arguments. So as you can see, it does a very good job. At this point, what I'm doing is I'm making GPT shift its bias in whichever way I want. I could shift it back, and I could say something like, use the opposing side's arguments, write a counter argument to dismantle their beliefs. And I spelled that wrong. But And then it'll take whatever steelman that is, and it'll give me the completely opposite side and rebuttal. So as you can see, this can apply to multiple different things when it comes to technical writing or perhaps persuasive writing, sales, and so on. Lastly, we did have, oh, let's go ahead and close that. Lastly, I did have an example. It was called graph prompts. And if anyone is familiar with knowledge graphs, that's basically what it did. It was able to feed in text and then create a network graph of the relationships between people or objects or things. However, the update kind of killed this thing. And instead, I've linked a tutorial that you could go over in your free time down here. And let's go ahead and open it. It's still able to generate. It's still able to generate these knowledge graphs through whatever text you feed it in. It's roughly about 16 minutes. So you could go after this workshop and work on this. This works great when it comes to understanding systems, or what I like to use it for is for exploration of topics. Seeing if there's an intersection between two topics. Why is there a missing node here? Why can't they connect? How could I connect them, right? And we will go over one more example of this. And this is interactions between GPTs. So this is getting a little closer to agents. It's when someone builds a GPT, and then it talks to another GPT, so they make your GPT do another thing. That's called an agent. Basically, AI systems talking together. There's a platform named Zapier that does this very well, and you can connect it to multiple different things, such as Slack, Facebook. That's what I use them for. Sometimes I'll do it on my Gmail for other things. There's OpenAI. And those are just some of the things that it can do. It can connect pretty much everything to whatever you want. So let's go ahead and by the way, this example does go credit to someone else, and I've linked their name in the bottom. I believe he is a developer. It's pretty simple. We could say, I'm not typing, okay. So Grimoire, this entity here, is actually a developer. To be specific, a software developer. What we are going to say is, we are going to say to build us a website. So create a website using Tailwind CSS about a coffee shop in New York. Specialize in Italian coffee. So we'll go ahead and let Grimoire do its thing. And this is essentially like having your own software intern. I've built a couple services, done some data mining, hosting of websites. If you know how to program, you know, like, this is not extensively, I would say, confusing or hard, but it just takes a lot of time. And that's the whole point of something like GPT. It's just to free you up of your time, doing more and less. So now we're going to say, send this code to at Designer GPT. So what we're doing now is we're having our software engineer talk to our UX developer. And this might take a little bit of, because what he does is he grabs the code, he'll back test it, he'll talk to a server, and so on. That's why it takes a little bit. So if you have any questions, please feel free to ask away.
Someone posted an article about how much energy it costs to query these things, and then it says, should we be asking, well, she says, we should be asking ourselves how important this is before we hit send. I just wonder if you've got a take on that.
Yeah, so it's very expensive, and that's, I think, probably a write-off in terms of research for the companies. So
This was in terms, I think, of just like energy and like.
yeah, and that is another concern. I mean, I think for the type of examples that we're doing today, probably does not mean, killing a bunch of trees. However, if people are doing research and you equate people's time into how much money, it can be a lot less expensive than you actually think. So it says your website has been successfully deployed in Replit. You can modify it here. So cool, so our website should be running. Okay, and here we are. And now we can explore the menu, and it completely automated this for us. Full-scale application, all you gotta do is write a couple lines, which I think is pretty cool. As you can imagine, this was 2 lines, basically. You could do what would have taken you like 5 hours in a couple minutes, and I think that's where the value is.
Can it update an existing website?
So not in this way. However, if you were to use something like Grimoire GPT or whatever language that your website's written in, connect it to the GPT or paste it, and then connect it to another service, if it has a plugin like Zapier, it could technically update other websites. You could almost make multiple systems to update all your websites, or even synthesize new ideas and update your website with these ideas. Remember, this is just an interaction between 2 GPTs. If we want to create logos, we want to create images, we want to create menus, recipes, and so on, there's also GPTs for that. There's a GPT for just about everything. And with that, yep.
Feel free to, oh shoot, my own phones. I'm just curious, like if you had an application, like any arbitrary one, this person was saying updating existing website, is Hugging Face the place you're gonna go to try to like find something that's already like a pre-existing model to do this, or is there like a better source for browsing?
So you could just browse on GPT itself to help you do this autonomously. However, Zapier, then that's why I put this image. So this service right here allows you to connect multiple apps and multiple AI things to create your own agents. I think if there was a part 2 to this whole workshop would be then taking all those basic stuff that we've learned and actually build services like websites, like financial like analyses services or markers, maybe writing peer reviews. But that's pretty much it for section 2. And part 3 is going to be enhancing data workflows with GPT. We'll go over a couple things, including core visualizations, statistical presentation. So in this presentation part, we'll actually use GPT for that. We'll go to EDA, data modeling, some limitations, and if you are really just stuck and GPT doesn't work, how can you take that environment to a local level and go ahead and do it? And we'll take maybe 7-minute break.